Look at a proof of the Pythagorean theorem. And just to give you a little bit of background on Pythagorean theorem proofs, we actually have somebody who proved the Pythagorean theorem pretty close to home. President James Garfield was a famous American who actually created a proof of the Pythagorean theorem when he was sitting in the Houses of Congress, which is really, really interesting. This is a different proof of the Pythagorean theorem. It's probably one of the most simple ones to take a look at. What we have here is we have a square right in the center, right? So looking at this large purple square, and you can see that each side length is c. Okay? So the area of a square we know is side times side, so c squared is going to be the area of this square. So we're just going to look at c squared as being that area of the square, and we're going to look at what's inside this square. You can see it's broken up into 5 different categories, and what each of those are. So we're going to use these green triangles to help us along the way, right? What I'm going to look at first is I'm going to look at this this purple triangle up top here. Do that in blue. This purple triangle right here, and I'm going to say, well, I have a green triangle above it. Now, if I take this green triangle, which I'm going to try and grab, and I'm going to try and move it, so if I take that, and I move that down here, I can see it matches up with another triangle inside that c squared. Okay? So now I have two triangles that I can shade off, right? I've got two triangles I can shade off inside. Well, what are those two triangles? Okay? To understand what those two triangles are, let's take a look at the two triangles actually put together. You have a rectangle. Okay? So you have that rectangle which has a base of b and a side length of a. Okay? Base of b and a side length of a. Well, the area of this rectangle, which is made up of the triangle down here and the triangle up here, the area of that rectangle is just a times b. So let's start building up the component parts of this c squared. So we're going to say c squared is equal to, in one part, you've got a times b. So when we look at the other side, we have the same deal going on, except the triangles are sideways. Okay? So we're looking at this triangle here, this green triangle here, and when we take the triangle opposite that, and we move it over, they match up and they make another rectangle. So I can actually shade in these two triangles now, as well as my other two triangles. So that's 4 triangles total. Right? Let me shade those in as well to show that we've done them. Okay. And I have this rectangle on the outside to calculate what the area of those two triangles are. And again, you've got, in this case, you've got a base of a and a side length of b, so you've got a and b, right? So again, it's just a times b, right? So we can add on another a times b to the inside of our square. Now this is where things start getting really interesting, and you see that we're left with this square on the inside. And this diagram actually shows us that this square, the length of the side is b minus a. And just to prove that, let's take a look at the side length right here that we've been dealing with the triangle. That side length there is b. This side length on the smaller side length of the triangle here is a. So we can deduce from that the side length of our square in the middle is b minus a. Okay? So we can say that we have a square right here in the middle, and the side length of each side is b minus a. So to calculate the area of that square in the middle, we have b minus a squared. Right? B minus a times b minus a. So we're going to put plus b minus a squared there. Okay? So we've got all the different component parts of that larger square, c squared. Let's play around with it. Okay, so just to simplify a little bit first, we're going to take these two ABs together, because AB plus AB is just 2AB, right? And we're going to add that to B minus A squared. Well, what is B minus A squared? Let's play around with that a little bit. b minus a squared is just b minus a times b minus a. So we've got a bit of distribution going on here. B times b is b squared. B times negative a is negative ab, which b squared. Negative a times b is negative ab. And negative a times negative a is positive a squared. We can again combine these two negative ab's together to make negative 2ab. And we have b squared on this side and positive a squared on that side. Let's bring all that together so that what we've just done here is this part here. So we have to add on that 2ab at the end. So let's add on this 2ab. Let's add on this 2ab at the end. And that, of course, is equal to c squared. Let's bring that down as well. And let's start cleaning it up. We see here that we've got a negative 2ab and we've got a positive 2ab. Well, they cancel each other out. Okay, so we're left with b squared and a squared, which we can write in alphabetical order to be a squared plus b squared. And that gives you c squared. And that is a very simple proof of the Pythagorean theorem.